Thank you. Have a nice. We'll see you next week.
Yes.
Okay.
Okay.
Thank you, Christian. All
Thank you.
right. So Laszlo, I just went live, and we are going to. I'm going to just briefly say, and you can comment on that. One of the things we are talking about with the Christian was here right now, and Laszlo, of course, is joining. Ceremoniously with me every week. That's a great thing. Laszlo is always present here. We thank, and myself. So we are all part of the committee. So we thank each other. But in any case, this is one of the possibilities for the T-shirt. And Christian also agreed that you can have like the TechNet Earth Global Sciences Physics Conference. We can put one more line, maybe the website. But Christian said that he is busy in consolidating the ResearchGate things, but he may have time. Um, you know, sometime he'll try to get some time to design by Monday or Tuesday, and he will post it on WhatsApp. So then we can decide, all of us, and Laszlo also going to put again the colors and everything. So we'll decide hopefully within the week, because we need that. He needs at least Laszlo needs at least a week to make the t-shirts, and we are coming inching closer to the conference. You know uh, Time. Uh, and within a month we are there in Budapest. So if you want to get the t-shirt before that, we definitely had to get it going by next week. That's the last time we have. So we will try something finalized next week. And all I want to do is about the schedule. There is slight change in the schedule because we have added a very important person. So initially the schedule looks like this. We start that Christopher has modified this with our discussion. So 9 to 9:15, my Christopher will probably about 5 minutes. He said introducing me and few people, and then I continue and with welcoming and all about 10 minutes. Then Christian will start talking. He has about an hour and 15 minutes. Then we have coffee break, and then half an hour. Gerd will talk. Uh, so I and Christopher will switch the chair of the session for the whole day. Then Laszlo will talk about half an hour on planetary erosion, and then I will talk about 45 minutes superluminal condensates, and then we'll have lunch, and then Christopher will talk about hour and a half. So we have some time here to adjust, but he will discuss more about his research and combined research, things like that. But then we'll have a coffee break, a small coffee break, and then Emmanuel and Antonio Olamandes, our associates, will talk about superluminal graviton vacuum. Then we have what is new is that here about 20 minutes, we have invited speaker, Dr. Muhammad Kurale. I'll be chairing that. He's a very top person. He's the overall chair of International Conference on Fundamental Applied Sciences, or ICFAS called, and I have been presenting in that the last few years. I started as a speaker, a small speaker about 15, 20 minutes. Then he made me an invited speaker about half an hour. The last year I was a session chairman, so Christopher and Emery Taylor could present also in my session, and we had a lot of time given to us, a fair amount of time, and we hope this year also he want to continue that and probably have more of our associates, our group people present in that session, because it's an international conference, mostly mathematics, algebra, mathematics, but other science are also there. So when they open up, there'll be a session on our physics, especially like I may put it as quantum cosmology, something like that. But that's we are discussing that. It's September, so he's a big person. So he will give an instant publicity to our thing, because he wide range. He's a professor now in Istanbul Technical University, but he had been the board, in the treasurer, in the board of regents, and all that in different universities. So he's a really a very high profile person. So he can give us almost large amount of publicity. So he's there. He will address us. So he may, Christopher wanted that if he presents, then he has to give an abstract bio and all that. But he said this is okay. So I don't know whether he just want to leave it that way it is, and he will address, which is fine for us, because immediately after that we start panel discussion, and these times are adjusted a little bit. I think it should be fine. Almost what do you call 35 minutes, 30, yeah, more than 30 minutes are there for panel discussion. 35 minutes, so that should be fine. Then we'll finish that, and then closing ceremony. And Christopher said that he has already booked a restaurant for that night. It's an Indian restaurant, so it has both vegetarian, non-vegetarian, so all of us can join there. And then we have the closing ceremony that night, and then the next day is hopping off of cities tour, like we have been talking about. That evening I will leave for Brussels, like I mentioned before. I will be in Brussels next day, hopping off of looking Atomium, place like that. Then I move on to Geneva that night, on the first night, and then hopefully I'll see some of the CERN. I don't have any specific plan, but I'll plan to visit there. Hopefully I'll see some part of CERN, and then see how we can understand the thing, what's going on there. A lot of things are in flux there. A lot of things are changing. So when I go there, I'll get probably, hopefully, better idea what's going on. And then the following day, June 3rd, I fly back to the US. So that's my plan. I think we all have our plan. And the last row, of course, he will come from Romania, and he will be there with us, especially that night on 30th, where we are all staying together. So I think it's all these things are finalized. The only thing, the T-shirt thing had be finalized, and I believe that they're on to it. So Christian, hopefully Monday, Tuesday, and we'll discuss, and then Laszlo make the final thing to and then Christopher, of course, all of us have to agree. Then he'll. We want a simpler design. We don't want the complicated things. Want simpler design, and then he can. He had assortment of colors and sizes, so I think we'll have enough to go on. And if he give me a week's time, he will have the T-shirt printed. So Laszlo, you can comment anything further if you have.
I don't have anything, because as I have mentioned before, Monday I will send photos about the T-shirts, and you will decide what color, what size do you need. And one thing is very important, to have some designs.
Yes.
It's not important to have the final final design, to have a 1, 2, 3 design, because in this case perhaps I can make other design too.
Yes, I want first batch. Yeah, first batch.
I want to see your what you really want. And that is why I am waiting, because before few weeks ago I made, but as you observed, that design was not so good, and that is why I have to wait.
Yeah. Now that Christian has come, and he said that he can give us Monday or Tuesday some design, I think that will help.
Okay, because in Tuesday. I will not will be at the work, and I will go to speak with the printer to have how many T-shirts we need. That is very important. It's another thing. It's very important to negotiate with the T-shirt printer, because I have got informative price of the printing.
Oh, okay.
And that is why
$22 to $25, something like that.
But it was another thing, do you know? And as we see, the final price of the selling will be, I think, about $22. of
Okay,
the t-shirt. But
that's fine.
I would like to remain at this praise. And
Yes.
another thing, only one case is the t-shirts are will be a little bit um, with a higher price if we have to buy from the t-shirt printer the t-shirts, because because the t-shirts I think it is on very well price, and the quality, my opinion, very good.
Yeah, sounds good. I mean, we can start with the batch first, and we can have a. If nobody replies any specific things, we can have assortment of colors and sizes, and
Okay,
that
Monday,
simply decide.
Monday,
Yeah, yeah. So we'll
Monday is
decide.
only very important thing to have the colors,
Yes,
because in such a case in one week I have to look for them,
yes,
to get them, because only one type of the size we have, because we have 6 size, and only one from each size we have only one, and that is why it is very important to know our what we really want.
oh yes. So what we can do, Wednesday is the last day. Whatever happens by Wednesday, that's you start. That's a good thing because the end of the month, we'll decide on Wednesday, one way or other.
Monday I will send the colors.
Yeah, that's okay. But Wednesday is the last day.
That is the most important
Yeah.
first,
Yes.
to decide how many colors we need from each colors, what size, and that is. And after that, if we can do in hurry to have some designs, not only one, minimum 3, 4, 5 designs,
Sure.
and in this case we can speak about why is good, and to decide to have a very cool form.
Yes. So we'll just wait for Christian Monday, Tuesday. But by if he cannot by Wednesday for any reason he cannot, then we'll go ahead and design. Go ahead with your idea of whatever the design and things like that. With if there's no specific things, the assortment of colors, assortment of sizes, then the whatever designs, like 3 or 4 designs, whatever you choose, we'll go with that. So Wednesday is the last day. We'll make the final decision. And when you start putting it, I will also put it in the our WhatsApp thing. That's Wednesday last day. Nobody responds. These are things we are going to do. So because that's a good day, because end of the April, then we start the T-shirt. The first week before the second week of May, we'll have the T-shirt, and then we are there already in the end of third week. The fourth week we are there in Budapest. So we need that time to get all the T-shirts to people and get it going. So I think that's a good decision making that we can do. And yeah, and the other aspect is Dr. Yagodin. Christopher was talking about Dr. Yagodin. So he has compiled, he said, a list of questions to him. And he said probably we'll have an interview with him. You can join us if you want to be in the panel. So I will send out, I'll be, main person to hold that interview if possible. He has not responded. So you want to interview him. Ask simple questions.
Excuse me, Rajan.
Yeah.
I don't like to be present.
Okay, no problem.
It is better if I am not present.
Okay. So I and Christopher will do the interview, and then we'll post it. Kind of.
And
We'll try to.
when I will have the interview, I without in communicate only in
Conference.
personally communicate, I will
Okay.
speak about in such a
No
case.
problem. No problem. Yeah, I agree. Thank you for
And
letting us.
when he will give the interview.
We don't know. So that's what Christopher wants. He has sent him email because he responded to him. So he sent him a list of questions that possibly we will ask at the interview. And he said that he has to send me because I'll be the person to decide finally uh, when exactly the interview will be and how it will be. Of course, I consult with the Christopher
And
about that.
excuse me. And
Uh,
if it is not a problem for you, if you can send to me the interview, and personally I give you my opinion if it's possible. If you like that this thing, but if not, it is not a problem.
okay. So I can probably forward what we had. I don't know whether I could show it here. Um, if we get off the thing, I can even show it here. But I don't know whether I want to record that thing. In the record. So once I can get off on offline after a few minutes. But I just want to point out to people. And very interesting. Gerd has talked about the uh, earthquakes, and you also mentioned, I think last time, about prediction, and I think I wrote there also what the problem
One
with the
one
prediction. Yeah.
one thing is very important. You have to know that how I have written in WhatsApp my totally concept comes from outside. I didn't what we didn't read the pre-existed literature. International got the idea, and it was connected to my previous works, what I have written before, and it was connected to the article critics about the plate tectonics that gave the inspiration.
Mhm.
And the one thing I think, and in this case I can tell you that in the case of the Alexander, one problem is that he has not long time or medial time forecasting, only short time forecasting.
Mhm.
And I can send you an I have promised you that, but I don't know if I promised you that to send you the article of Vyacheslav Nagorny.
Ah.
He has a concept something in case of the long time and the medial time of earthquake forecasting. We are close, and has such a aspects that I don't want to talk because we have discussed about it personally, and that is very important. And as you know, I have written 2 articles of critics of his prediction in case of Japan. Did you see it?
I'm not
In
sure.
case of Nankai, in case of he made a prediction before 4 years ago,
Ah,
the 6 months before the event, made a prediction in the zone of the Japan Nankai zone, and
yeah. Yeah.
it is very important because he gave something, and I can speak about it only personally, and it should be good for us to see and resolve how is made him. I saw something mistakes in his works, but in generally the concept who is coming out is very good.
Mm.
And we that is not same with Yagodin. Yagodin only in short time, in few days ago of the happening event, he makes a prediction, and in case of the Alexander not Vyacheslav Nagorny, he made before six months ago the prediction, and I have a work what was made by his son Volodymyr Yagorny with Valentino Strasser on prediction of volcanic eruption in the South Pacific, and he made before 2 years before the event. It will be happen. It would be happen in next years in March or April. I have the article, this article same, and I have made an critics of this article, but only the authors did have it, and same only particularly is good if we see, not the public, if you want.
Yeah, I think you are mentioned that they made a lot of the things in Italy, especially, but many of things didn't come out like that. They said this won't happen, and then it happened. And in the other cases, they said it won't happen, and it happened. And the other cases, they said it will happen. So there was a lot of things which are not.
But it's very interesting. But it's very interesting in case of the last earthquake in Turkey, and mentally, before 2 days, I have thought about the Turkey, but that is only perhaps, I don't know what was it, and it has a connection with another event what was before about 2 years 6 months ago. It is very interesting. And another thing, because exists possibility, but we don't have that is very important. We have to have instrumental data and very well interpreted this data, and after that can we decide that it is exists true danger or not. In case of in case of Turkey, in the next month, in May, exists possibility to happen another big event.
Really?
But only in that case, if the possibility actually exists inside of the zone, but we don't have information about it.
Oh. So in the Turkey somewhere, we don't know exactly where it is in Turkey.
We don't know that the seismic, that the energy, that the condition for the earthquakes is what's consumed or not. That is very important in case when have a large earthquakes to have information.
Yeah. The Richter scale.
Example, we have a very good example in case of the China, when in 1965, 85, I don't precise, they predicted an earthquake, and after one years after the event, happened another big earthquake. And these earthquakes, they don't predict it, because he thought that the energy was consumed, because it is written down in my critics to the article of Vladimir Nagorn. What was the second article of critics, because at the first article I have only 1 year of the after getting the inspiration about the earthquakes, and I needed to evolve my my concept, and that is why that is very important to have data about the place and the position of the instruments. In case of my method, it's not using same concept like in case of Alexander Yagodin. He has a good concept, but we don't nothing that we have the same concept, or we have separately another concept. He's speaking about my my prediction method that he has ready and is gotten, but that is it is not a good opinion, because if I have something new what he doesn't have, in this case we together we have a better method.
Yes.
In every time more people methods is summarized. In that case the method will be more better.
Yes. Yeah, we should, that's the idea for me also. I believe in teamwork. That's why we have the TEGS, that people come together, find a common, ground, and try to work with that. That's my main goal. It has been fairly successful, because initially we had a lot of problems, and I was struggling like 20 years from after 90 to 2020 up to about 2020, until Emmanuel came. I was struggling to, I was putting in science forum, and they were very, very nasty. And then I went to ResearchGate. It was little better. That blogging helped me to and also publishing in a important journal. They were totally, they're totally rejecting everything. They don't even consider. They don't even read the papers. Then
Rajan, I have opinion, and we when we will be in Budapest, where we meet personally, then will be easy to discuss about such a things, because exists a lot of opposition against us in this case, and another thing that the mainstream in majority case stealing the good ideas, and they don't let us to do something. Yes. Stealing our concepts and put everything against us to do something very well.
Yes.
And we are not and we are not getting anything support from the state, nothing, and that is very, very hard position, because in case of in my case I have a place, and only very small money needs to make instruments in that place, and to collect some information, and this information.
Is that in Romania?
No, it's not. It is Romania. It's in a very is. I am working in the clothes selling in Földes.
Which place?
Földes. I will send you the map if you want.
Oh, in China, you mean? China? No.
I will send you. I wanted in January. I thought about to make the conference there, or in Hajdúszoboszló, and it's not far from the Hajdú-Szoboszló. It's about 20 kilometers from Hajdú-Szoboszló.
Where is that? Which country is that?
It is in Hungary.
Hungary. Okay, not too far from where you are.
But the main problem in case of the Földes that is not placed in the seismic zone.
Oh.
But it is not so big problems, because if we making a observational station, you can collect mondial data, and from mondial data also you can conclude what can example happen in the east or the west from the point. In case of Hungary, the collected data is good for the Italia or for United States too. In case of California, because this place that is dangerous place in case of seismic activity.
Yes. Because of the faults, the San Andreas fault,
and that is important if you can have something connection with the SPETS, with the Californian earthquake.
Yeah, I try to, we'll get more project. We'll have a project, along with Christopher, because he's in the disaster thing. And he may join, I don't know, JASA, someplace like that, then it'll be easier. But even otherwise, we can have a project, seismic project or something like that we can have. And then we work together, and then we contact the people. Then we have our conference that helps us, because we'll say, okay, we presented in the conference and these people were there. So it'll stir the interest. See, that's what I found, that you have to stir the interest of people, and how to do that was the biggest problem. I think we solved that problem. I solved the problem with the manual. We went to second tier or third tier publication, and that helped us to and the upcoming journals, and it has helped us, and many people are joining that. Recently, I found some of the collaborations what I am doing, like gravity is not a fundamental force, is one of our outcomes, and many people are now saying there are top scientists, and I saw a recent publication that shows gravity may not be the fundamental thing. So some other force, some other things are going, mechanism, and that's what I am talking about. My thing is some mechanism is going on the supraluminal level, and this mechanism which creates the distorted field is the main thing. And they believe that Big Bang is not the one. There are multiple things that happened, events. So those things will help us, and then contact gravity, things like that, and come up with the proofs. And I have a way, I did that recently. I published with Manuel, who is he want to join. I told him about you, so he said we can work together, because we published journal of physics, optics, modeling of binaries. So I am in quantum cosmology. I'm becoming more and more quantum cosmology, binaries with the quadratic equation. This is about the, of course, this is about Einstein, Maxwell equation, things like that, which is astrophysics. So we published this together, and then it's essentially solving general relativity equation. So I am the author with second author with Manuel Malaver, and so he analyzes all that, because he's a professor of astrophysics. He does he can easily do that. He has all the program. Then he come up with that and compare with the experimental data. And then I have put my comments also, where how this helps our problem, helps us, our my model helps in figuring these things out about Lagrange and everything of action, and how the brains theory will help in do. So we have a lot of publication like this together. So that's one thing. Oh, I'm sorry. I didn't. I got off the screen.
No problem.
Yeah. So let me go back to the screen, and then I just share, and then go here. What I'm talking about is this. Yeah, Manuel Malaver. Uh, we are published together paper modeling binary system, like I was mentioning, cosmology, and solving Einstein equation, general relativity equation, to this standard thing that astrophysicists do, then compare with uh, the the experiments, telescope and measurements. Then I also added our things, that my thing, especially the. So these things corroborate things, and we are trying to figure out also about how graviton may play important role in these things, and we can find evidence, uh, in the actual. We have a publication also here.
But Rajan,
Yeah.
I think that if I have another concept about the graviton is a problem, not problem, not
No, no problem. Because I am,
okay.
see, I work with the different groups.
My graviton is it's somewhat is connected to your micro micro black
Black
hole.
hole. Yeah, that's my main concept. The micro black hole.
And another thing, when I wrote the a priori entity, and it was expanded in the scale of the universe. In this case, exists another approach, and that is not concordant with the black hole of the universe.
Okay.
Because I will show again personally what is my concept about it, and
Okay.
we have to find something resolution to see if it's good or not.
Yes.
I think it's not so wrong, but but in case of planetary erosion, I have begun to build a project, but it's very hard, because when I wrote the article, that is only attention was to demonstrate that the planets how are eroded, and from them become draft planets and asteroid belts. But I have a look on the actual literature about the erosion of the Earth, and it is it's very lack of very important thing. It's not present in the actual literature, and that is again a problem. Example, we don't have literature about the volcanic erosion. That is not exist in literature. Doesn't exist seismic erosion. Doesn't exist tectonic erosion. That is all fundamental erosion forms what is present in the nature, and that is in the literature of the geology. In literature we don't have, and that is why that is why it is hard for me, but I will try to make it possible, because that is very important in case of planetary erosion. Only with these three type of erosion can explain how happening the planetary erosion, and after that it is very important that why these Rockies can go away from the surface of the rocky planets. That is very that is.
It better happened
Excuse
in
me.
Mars, other places like Mars. They're studying Mars, right? The
Yes,
Martian space. If you look at that, it could have happened there. There is some evidence there showing there could have been a big lake recently, today or something, yesterday or today. They
and
showed a big.
excuse me, and if you can have some image of two crater what can be connected to the Phobos and Deimos, two moon of the Mars, because in my opinion, the Phobos and Deimos came from the Mars.
Like moon, like the moon of Earth.
Our moon is same. It was connected to our Earth.
Yeah.
It's come from our Earth. How is son of the Darwin has mentioned it. That is my opinion. And
Yeah, actually, I mentioned last time, I think I like this idea that our Earth was either a black hole or red giant. It was a form from star, from sun or star, from galaxy, the sun. Then the sun purged out a lot of starlets, and Earth was one of them. But then the Earth then formed a red giant because of its particular mass. It formed then into a black hole or a red giant and make Pangea, right? One planet, and then you have erosion from meteorites, everything, and that fissure occurred. Then you started the it's a nuclear fission. Then from nuclear fusion, the fuel ran out. Then it all merged together and became and then inside nuclear the bombardment started a nuclear fission process inside, produced the magma, and then produced all the volcano, everything, and then volcano came out, and then you have this methane and other things forming, and then water. And
in case of Earth, I think the energy comes from the disintegration of the Earth nucleus, and
yes,
that is why the Earth has a temporary, not a big but a small expanding phenomena, but because the plate tectonics, I think, is not a good theory. Only partially is good theory.
erosion. You're talking about erosion, right? Erosion may be the main thing.
Yes. And this case, I think we can find some resolution too.
That's good. So recently I did, yeah, I think we can combine the astrophysics with geophysics, and then the astrophysics tin
In
paradox.
geophysics, I don't like to forget. In geophysics, in case of the works of the Vyacheslav Nagor, I will send his article to you, and because you are very well trained in math, to test his formula, and I will send to you where I think his formula is not good, because his formula has mistakes, because he is using a radius of the Earth, and I think in such a case that is a problem. Or if we use the radius of the Earth, we have to use another distance from the epicenter of the hypocenter of the predicted earthquakes in case of his formula. And I will send you majority in formula of his is very well. He's using the moon effect, but that is not moon effect. because it's a effect of the Earth's core. What we every gravity changing in majority case is connected to the Earth, and another effect is connected to the sun. Moon has not a gravity effect on the Earth, but can disturb the gravity effect of the sun. That is why sometimes when we are feeling gravitational change and we are saying that is caused by the moon, not gravitational effect of the moon is gravitational effect is perturbed by the moon with his position.
Yeah.
Do you understand?
Yeah. So you can create an analog. You know, analog in circuitry, electronic circuitry. You are like a diode, right? Diode. So Earth and Sun are like diodes. Like, you know, the Sun is the one that is like producing the source, and the Earth is.
I have totally concept about it, Rajan.
Yeah.
I have totally concept. I have totally concept, and I have verified it. But exists one thing very interesting. If that is true, or my concept about the a priori entity build up the gravity is wrong, or the theory of the Galileo of the he's mentioned some no, I don't find the word.
Moons of Jupiter or something, or Saturn or Jupiter.
The free falling, every object are falling same form on the Earth, and if my concept of the a priori entity build the gravity theory, in this case, that is the Galileo. This concept is not work in horizontally horizontally effect. Do you understand? If a object, example, we have a very huge horizontally object parallel to the Earth surface that not will fall in same speed like a punctual object. The punctual object will fall in better speed, in a higher speed, like a object with a horizontally space.
Yeah. So I talked about.
But if that is it not good? In this case, my concept of that a priori entity is not good, and in case of this, exists another thing that the Earth is not so mass, that has not so large mass. How is we consider? It has a smaller mass, and that is why that is somewhat can be explained how it is moving, orbiting around the sun. That is very important thing, because the Earth's core is not made from iron and nickel material, is plasmoid and has no high mass, how we consider in the mainstream science, and with this concept, it can be only in this case my concept is works. But as I told you before, everything I made, tested, they have been works. And I think I believe same in my concept. And in case of the effect of the moon, same, it can be very easy demonstrated that that how it works. Now let's do
Yeah,
you
yeah,
show
yeah.
do you make in
So
the
I made a
diagram?
program. We can do similar thing on your program. I mean, once we have your equation, we can program it and then show simulation. So the idea, this is our project of geophysics project. We'll start after our conference. So this
I
will
am
be
not
part
so
of
good,
that.
Rajan. I am not so good in geophysics. I am only in geology,
Okay, that's fine. We'll
interpretation,
combine.
and concept.
No problem. We'll combine and make a project geophysics. You will be more on the geology side. Then I will do the math, the simulation math, physics, things like that. So we can combine. Um, so this is like a twin paradox. It comes from the general relativity, Einstein's. So I programmed it and kind of simulate. Okay, in this case, this is the real time. Real time doesn't depend on the gravitational effect. The proper time depends on the gravitational effect, and that's what we are seeing. The twin paradox, when you talk the famous thing, when somebody else travels into space, comes back, they will be younger than the same person, the twin on Earth, for example. So this is because of this time dilation according to general relativity. But I think there is another explanation. We will start. The other one is about the 3D space of the twin paradox, and then you can see that how that works. Let me run this one again. So you have this the 3D space. So if I run this one, so you have these. You can see how the time changes with the velocity and things. So I can adjust the velocity. I can increase the velocity here. I mean, this is not so good. Trying to combine with artificial intelligence to get better programming, but it's just a start. We can improve on it. So it gives a 3D map, and then we can actually see you know how that moves around the space. We can move it around, and we can get different positions of this thing. So I think these simulations are good, uh, you know, and so these are some of the things that comes from our understanding of general relativity. So this is good. And then I mentioned about last time about the my other thing. And in that one, I talked about the Lagrange. Remember, I talked about the Lagrange thing. Um, yeah, this is the presentation I'm talking about. So Lagrange, if you remember here, talked about the equivalence. Let me see. Yeah, this application here, it talks about the equivalence that I can get a static equivalence principle. This is where the what you are talking about. Let me show as a slide beginning. Okay, so let me go there. It will be easier to see. Okay, so you go here. So if we go here, we see that this equivalent. See, this talks about the direction of the gravitation. What you are talking about, it distinguishes between, it comes from Lagrange. I start from Lagrange of action, that S equal to L integral of L dt. So from there, I apply for the classical physics situation. So then I show that the direction of the gravitational field, that's very important. The vertical direction is the direction of the gravitational field. How the scalar thing, the equivalence principle holds good. What happens in the horizontal thing? That's what you are talking about. The horizontal is not the same, because this is true, the direction of gravitational field. However, this will change for the direction of the horizontal. For the horizontal, this equation will change. That's why we see a different result that you are talking about. You know, the horizontal is not the same as the vertical, because
Ryan,
yeah,
only one thing: the gravitational field is dynamic,
yes,
and has it's something lack of the spatial phase in my concept, and that is very well can be connected with the Einstein concept, because they are only similar. In my case is is lack of the space phase, and in case of the Einstein is a curvature of the space continuum.
yes,
And in my case, the gravitational caused form is lack of the space phase. It's a natural thing,
mm-hmm.
and can be connected with the work of the Einstein. The Newtonian gravitational formula is only when we are balancing one something. Only in case of mechanical contact works. In other case, we have to forget the Newtonian gravitational theory. It's used in close on the surface. We can use very well, but in reality, the explanation is not so good, like in case of Einsteinian explanation, because the Einsteinian theory was well verified and demonstrated. Only one thing that he had given only geometrical explanation. He didn't give a natural explanation of the gravitational effect. And if we can resolve, we will have a very good gravitational theory. And I have some ideas. I didn't mention it in anywhere. And if we can use in this case, we can eliminate the time or something. We can give electromagnetic formula for the gravity. And I have seen an article an article made by a Chinese. I have the idea, but I didn't write it down, and he made, but perhaps his formula is not so good. Mm-hmm. He used, and I will send this article to you, saying, now I have two promises for you. First, about the Vyacheslav Nagorny's article, and in case of the Chinese article, to see. It's very simple. It has, I think, it has not so good interpretation, because he hasn't given the explanation same, but using formula is very interesting, because I have the same idea too before he's published his article, and that is very important to see same, because we have to go in such a direction, and what you mentioned, what you have shown before, it can be connected well.
Okay, thank you. So one of the things you
More,
talked about Newton's law, the Dom paradox is a loophole. I mean,
the Newton's laws, I have concept which can be disproved, Newton's law. I have when I wrote the article about the a priori entity and the graviton article, then I have it, but I didn't like to make this article. It has problem, and his problem it caused by the gravity interpretation. In case of the mechanical laws, if his laws is used in case of mechanics, it's very pretty and very good, but it can be built inside in case of gravity, but because it is in contradiction. When a free falling object is free fall, it doesn't affect it doesn't affect force on his, and in this case immediately the concept of the dynamics principles of the Newton, it can be accepted. But in case of mechanical other things, it's very good.
Yeah. So for example, time paradox. What I'll just this video will show, but I don't want to show this video right now. But the main thing is that the Dom paradox. What's happening is that you know there's you can have a dome here and you put one girl, this is like Jade, one girl who is a physicist, who has shown this dome, and you put a ball on top. It will rest for a while. It won't immediately drop. And why happens, I can explain it. That's why I say initially it will have a static equilibrium, it creates. Then because of the each point has gravitational field everywhere, so it will take some time. Actually, you can solve this equation from my thing, and you can find the time. People have solved also partially, and it's on that there's a little bit time it takes for the dynamics to come in. It's like the wave function. For example, the wave function of the time, the wave function of the gravity act together, and there is a finite time, and then the ball will start rolling down, because of the gravitational gradient. So that's interesting about, but the Newton law cannot explain that, the Dom paradox. So that is the very important aspect. So that's why I want to point out there's a static equation, there's a dynamic equation. So the static equation is based on this equivalence principle. Dynamic equation is based on the wave function interaction between the gravity and time. So that's the main thing. So that's one of the key things that I'm trying to bring out. I'll show this in our conference also. Hopefully, that how other things also I showed you. I showed everyone. So that's the interesting aspect that comes out there. And so these are quite interesting things. I can show briefly maybe here the Dom paradox. This is the Dom paradox. So if you do this here, so he starts here. Oops. So see, it stays.
But Roger, but if the gravitational horizontally changing, the ball will move in that direction where the gravity lack of the space phase is bigger.
Ah.
And in case of the ball lightning moving, can be explained very well, which was not explained. Why the ball planing are staying in one place and sometimes is moving in one direction. And as I told you, after the meeting, I want to go in a place where was observed a ball lightning, and the ball lightning went into the house, and I want to make some measurement to verify if my idea is correct or not. And I think that it have to be correct on only in quotation, because in China, when I made measurements, there was that measurements gave this intuition to resolve this moving, why the ball lightning go inside the house and why the ball lightning move in some direction it's connected to the gravitational effect. Where is the gravitational effect is bigger, the ball lightning will go in that direction.
Yeah, I mean, so the direction depends. That's why I say the static, there's an equilibrium it creates, like I say, but the dynamic, the direction depends on the wave function, how the wave function interacts and creates a direction, you know. And then your space phase may come, maybe we can combine the idea, your model.
Yes, can be combined. Can be combined. I am sure that can be combined, because as your algorithm and your formulas is built on the Einsteinian concept, and in this case
more general than that, because he didn't talk about a time wave function. So I'm talking about time tensor and the wave function and the gravity as a gradient. So these two are two different things I'm talking about. So they interact. So gravity is not necessarily the fundamental force. You know what I mean?
Not a fundamental force. Not.
I think
it is not a force.
Yeah.
The gravity is not a force.
Yeah. It's not a gradient. Just a gradient.
Yes. It's a gradient. It's connected. It's connected to the example in such objects like our Earth or our Sun, and it's connected to its core and pushing of the outside of the rock shell of the
pressure.
Planet.
The pressure, things like that.
Pressure, exactly. Pressure of the exactly. In case of the sun, we don't have such a things. It has a pushing effect. It's something similar with the sun wind, but not as a sun wind, and that has a pushing effect, and interaction of the planets mass. Planets immediately I will tell better.
Matter.
A planet's inertial stage, and with this can be very well explained why the planets are orbiting in such a way how is we observe, and exist other proof to it same.
Yeah, actually inertia can be explained.
And that is why example why the Jupiter is more far from the sun, because because his inertial effect is smaller, more smaller than in case of the Earth.
Yeah. So
And
the can be explained on the basis of I mentioned static equilibrium, right? The equivalence principle. I talked to you about the static equivalence principle. That explains the inertia. That the dynamicity is the gravitational mass. That the gravity effect is the interaction of the wave function, the gradient of the gravitation field, and the time. They interact together and they create this. So the electromagnetism come into picture automatically, especially the fundamental
Rajan,
magnet.
this effects it's in reality is connected to the natural stage, how is stage of the Earth not close, and how is stage of outside. This effect, and it can be very well described with your formula, what you have mentioned now, and that is very important to these things to bring together.
Yes.
And I think I think that is will be a very good thing to be described such a things mathematically very well.
Yes. So if I want to show, I can show in the other screen. What I mean is, you have. I'll show after I write this one. So you have almost like a Feynman diagram. So you have time and gravity. Then you have electromagnetism. So that is the mediator. Is the entity, time, entity, gravity, gradient. So then you have the mass. So then you have the energy and mass and energy. What we call the mass and energy. So if I show this one, see, I don't know whether you can see this one. So this is what I mean. So you have the time, the wave function, and you have gravity, and you have the equivalence principle I talked about, A, T, or plus G of T equals 0, equivalence principle, the static equivalence principle. Then the wave function. So the psi of
And no, I can mention now that but the equivalence principle only in case of the vertical. If a vertical
yes
case R works.
Yeah, vertical. Yeah, along gravitational direction. It could be anything. Gravitational direction. On Earth, it is vertical. They are vertical. No, that's our sense. That depends on the sense. But it need not be vertical. And the gravitational field can act any direction. But on Earth, because of the sense, because of the way it works with the magma,
it's changing vertically and changing horizontally too. And sometimes the horizontally change is null. In case of the ball lightnings, in this case, the ball lightning will remain in a single position. But when the horizontally change exists horizontal change, the ball lightning will move in such a direction where the gravitational effect is stronger.
Yeah. So you see that magma ice core, this defines the direction. So the direction defined. So this is the direction that's defining. So then we say on Earth here, you say like this one, we say vertical, right? And then we go this way, it's called horizontal. So horizontal is along this sphere, along the surface of the sphere, where vertical is perpendicular to that. And that's because of this. So we have this as gradient of gravity and that time wave function. So when we interact together, we get the the gravity effect, quantum gravity. So this is how we get quantum gravity. So the time, so we can combine, and then it produces the mass and energy, and you have the E equal to mc square, things like that coming into picture, the equivalence principle. So so the m here equals E over c square, we call it. But again, these are questionable. So this is E equal to mc square. So this is how, but this is Einstein equivalence. But I am talking about from there you can create static equivalence principle, static equilibrium equivalence principle along the gravitation. Very important, like you mentioned, along gravitation direction only. The along the if you go horizontal direction this way, the horizontal is along this direction. This is horizontal, and this is vertical. So if you go horizontally, it's different. Then you mentioned space phase, right? Space phase.
I will make a
Yeah,
picture
last
about
law.
yes.
Last law space phase. This is Rajan's.
And I can draw inside.
Yeah. So yeah, we can discuss that at the conference also.
I will send a picture. I have pictures about it. I made a picture. It's somewhat correct, but I need to send another picture. And the picture is very simple. And we have forgotten to mention that the Earth rotation same has an effect on the gravitational field. The scalar gravitational effect also has effect on the gravitational field.
So after conference, we'll do this one.
Lot of things has effect.
Yeah. So this is your ball lightning. Ball lightning is happening here, right? Ball lightning. Is happening, right?
Yes.
So this is yours. But ball lightning is happening like this on the surface. So the horizontal direction.
It is in case of the surface ball lightning.
Yes.
When existent ball lightning doesn't terminate the lightning effect, it can be created ball lightning.
And then it comes out. Then it comes out,
yes,
right?
Yes.
Comes out somewhere here also. This is different.
And how you made on the picture, if is good, the ball lightning will move in high direction, in vertically from the picture.
This is actually vertical. Actually, this is
Yes.
we see because Earth is rotating, it's actually vertical. This is vertical actually.
Yes. Not, but horizontally. If we see on the picture horizontally,
This is
we
horizontal.
will
Yeah.
we will move in the picture in that direction. Yes. The
Along-
ball light will move in that direction.
This is horizontal. Yeah.
Yes.
This is
But
horizontal. This is
on the
vertical.
picture, it seems in a vertical position.
Yeah. But see, the vertical and horizontal depends on that. So this is
Yes.
horizontal. Horizontal. This is all horizontal.
Yes.
And this is vertical.
And horizontally, where you are drawing in that direction, the gravity effect is it is higher.
No,
The direction that direction we have a higher gravitational effect in a horizontal position.
But gravitational effect is constant.
No, not Ryan, not Rajan, not. It has difference. I have verified.
Okay.
I have verified in China.
Along the surface, gravity changes. Along the surface, gravity changes. I thought only along.
Yes. I have verified. I made lot of. Yes. I have lot of measurements.
Oh, I thought vertically only gravity changes.
And also in case of vertically, same change. Vertically are changing and changing in horizontal direction.
Oh, the gravity. Oh, that's interesting.
Yes, gravity space. I have the monitor described data because I have made measurements and made minimum in 10 days. Every 10 in every 10 days, I made measurements in similar times, and the measurements results have somewhat similarly. In same position was made the measurement.
This is horizontal. This is vertical.
Yes.
And so according to last law, then gravity will change horizontally as well as vertically. Is that right?
It's okay, but one thing is very important because increasing and decreasing horizontally, it is not constant. Do you understand?
Oh, okay. Yeah, that's what I say.
If we moving, example, in one direction, it can increase the gravitational effect, and can we are going in bigger direction, will decrease again. It's varying. It's not constant.
Oh, okay. So your experiment shows that.
Yes, it's a very simple experiment.
Oh, okay. Okay, that's interesting.
And the experiment, as I have concluded, that it was affected by how is where was the measurement was made. Example, if it was made on the asphalt, it was smaller. If it was made on the ground in soil ground, it was bigger. It depends lot of things.
Could be resistance force because of the mass, because of the tension. The tension is changing, right? It could be the tension, the tensor, the stress tensor.
Changing. It is caused by in my case by the space phase. If the space phase is bigger or smaller. In case of the space phase is bigger, has more space phase matter. In that case, the gravity is smaller. If the space is lack is small, it has the density smaller. In that case, the gravity is bigger.
Ah. So yeah, so it could be stress tensor, the
Yes,
effect of the
yes,
stress.
yes.
So that's Einstein equation, the
Yes.
stress tensor is Einstein equation, Einstein GR, that G mu nu and T and everything, Einstein's general relativity, G mu nu, and then T, and then all that R. So the GR equation. So the stress tensor is changing, uh, is changing. That could change the gravity, the effect. Uh, Somebody was talking about observer effect, things like that, but I also mentioned before. So these are interesting. We can work on that, in our project. We'll try to work after our conference. We'll get to it. So we'll combine our things together and then we'll try to simulate and things like that. Your experiment. And you explain
And
the
you can
geological.
you will have Rajan, you will
Yeah.
have also opportunity to verify too.
Yes. So it's interesting. So that's the main thing here. I think that's it. So, what we talked about again is, these interesting projects are there. Then we talk about the seismology and other things. Uh, and then, so I think there is a connection. How the Earth is connected with the astrophace, that's very interesting thing, because things come from other outer space, how it affects the Earth. We don't know still completely. We know about meteorites, things like that. It's probably ended dinosauric age or Jurassic age. Um, but I think inside the magma, how the fission process started is another interesting thing.
In my concept, the Jurassic was and after Permian was a very high activity, volcanic activity, and
Oh,
that was why a lot of the animals and plants was destroyed in this
ah,
case,
it's because of
and
volcanic.
and after the Jurassic, the cold surface, the Earth surface have begin step by step to cold, and in case of Jurassic, because was the an effect, a bigger hot effect from the inside of the Earth. That is why it seems that the gravitational effect was smaller on the Earth surface, and perhaps that it was caused by because the atmosphere pressure was bigger on the Earth surface
So if there is more or
because
volcanic,
cold and the area concentration.
so if there is a volcanic eruption, the gravity changes.
Yes, yes. It have to we have to verify and
Uh,
and uh, and should be very good thing if we have a connection with Iceland researchers
uh-huh.
and to get information from them when they have and have had have had eruption. What happened with the gravity? In my opinion, the gravity effect was increased, and
Oh.
and exist other conditions when the gravity is changing. It's a lot of things affecting.
Mm. That's
And
why world
in
university.
and excuse me, it's not its connection to the present discussion, but in case of text, we can have another very important thing. Example, oil and gas exploration, because I have ideas in connection to the oil and gas place. It's not it is also same outside of the current theory which is taught at the university. And if we can can connect it to text, it is very, very important thing too.
Yeah, actually, that's why World University are talking about. We established that we can have a chapter in Iceland, then we can have a conference there also. Then we can, highlight the high thing, how the volcanic eruption changes gravity, things like that. So those studies, specific studies, will help, project, your geophysics project, that we can take it to different places. That's one of the idea, whether global warming is true or not, things like that also. Because some of the people are shifting all the things, glaciers, everything. The global warming is shifting all that in Antarctica and Arctic Circle, and that is creating the volume of the sea to rise and also change the temperature. We see the fluctuation in temperature a lot here, a lot more than before, because sometimes it's like spring, sometimes it's like summer, sometimes even like fall, snow and things like autumn and winter. All these seasons are mixed up because of the global warming, probably. But many people don't believe that global warming, including Christopher, that it could be a different phenomena. But whatever it is, something is changing. Uh, the effect, one effect is affecting the other one. Like you mentioned, volcanic eruption is affecting the
Exactly.
gravity.
Each effect has a effect. Every effect has two other effect. It's
Yes,
all is a system.
combining.
It's a,
Yeah.
sometimes has effect, bigger effect, sometimes smaller effect,
Yes.
or negligible
So
effect.
yes. So these are very quite interesting things. I think it's worthwhile because we are identified areas. So we eliminate certain areas, but then we concentrate on certain specific areas. So that will help. This modeling and things like that is helped a lot. So theory is important from that standpoint because we can focus. We can eliminate a lot of things. That the theory does help in that. The math theory helps in that, but that's it. Then we are physics have to take over, and and then we'll describe by physics the rest of the things, what's happening, the observations, the measurements, uh, and then try to combine the two and see how, try to predict some things and see whether the prediction is correct. So these are very important part. I think we are, people used to do that. The big thing about classical physics or Newtonian Galileo, the partial success is because of scalar aspects. You can measure all these things: velocity, the distance, time, velocity, all this can be measured. But in quantum mechanics and even general relativity, that became difficult. That's why it's difficult to verify those things. So we have to scalarize things. A lot of things will be tensor or vector things, but then eventually we have to create a scalar equivalence, and that will help to verify the thing. Very, very important. So anyway, I will close this end stream. If you have anything else to say, you can say that. I will close this. Then we'll just briefly go over Dr. Yagodin's thing. I don't want to record that here, because we will see the result. I don't know how he'll be. It'll be confidential for now between us. But then once Jagodin comes and he's interested, then we'll see. We will publish the results in text or some place like that. And I think we can, do that.